Hello everyone, and welcome to this year's edition of Azure Back to School for 2021. My name is John Folberth, and the session we have here is Infrastructure as Code for Azure, and we'll be talking about both Bicep and Terraform. And before we dive into it, just a little bit about me. I am a Senior DevOps Consultant at OST based out of Grand Rapids, Michigan. You can find me out there on Twitter and then also my own blog. I am a Microsoft Most Valuable Professional, MVP over the Azure space. So feel free to reach out and connect if you have any Azure questions or DevOps related things. We'd be more than happy to talk to you. So getting started and kind of level set with what all we're planning on covering here, we'll go over what is infrastructure as code and why there's a need for the overlap between both Bicep and Terraform. And then we'll talk about each one individually. And if you notice there, I'm not trying to pull a fast one on you. Well, it's ARM/Bicep, because if you are familiar with it, then you realize that Bicep compiles into ARM. So you really can't get around talking Bicep without talking about ARM. So that being said, the first piece here is, what is infrastructure as code? Infrastructure as code is how we define cloud resources, and we define them in a code format so that we can go ahead and deploy across multiple subscriptions, multiple regions, those kind of things. All clouds have them. It's not really just an Azure specific thing, but AWS and GCP both have their own infrastructure as code platforms. We also do this to prevent drift. So if I'm continuously deploying my infrastructure as code, think of it maybe as configuration of different items, and we're not going to let someone go in and manually change things. It'll just get reset the next deployment. It will destroy resources and redeploy as needed. So with Terraform and Bicep too, depending on how you configure it, you can destroy resources that have been removed in your infrastructure as code file. So then it'll clean up for you on deployment. Infrastructure as code can be incorporated in software delivery pipelines, which is a great thing to have. I know there's an open dilemma out there, but I'm a proponent of deploying your infrastructure as code with the application code, just because you really can't have one without the other. If I deploy the infrastructure without the application code, then we're just paying for things out in the cloud that we don't need to be paying for. If I go ahead and I can't deploy that unless I have infrastructure. So it makes sense to kind of incorporate that and treat the infrastructure as code as a true code repository and code base. So why do we need these languages on top of infrastructure as code? So taking a step back there, the Azure native solution is ARM, which is really a JSON file. It's not really a language. So these languages have been created to aid in the create and execution of configuration. You get some advanced functionality with looping, conditionals, complex objects. It helps lower that barrier of entry. Other things you can start getting into is abstraction of module and reuse. So those are some key components that kind of drive the need for some sort of language to help deploy things to Azure at scale. So let's start going a little bit backwards. Let's start with the overlap. So I think there's a lot of similarities more than there are differences between the two. So it kind of, for me, it helps to, let's talk about what's similar between the two. So I mentioned about there's different components for reusability. Both Terraform and Bicep use what's known as modules. So a great example of this is, let's say if I need to deploy 10 VMs, I can define my VM as a module and call that module 10 times and create 10 VMs, which is very nice. And not to mention too, I can incorporate modules in different areas as well. So if I've defined a module, I can reuse it in different projects potentially. Then we also have advanced objects, so we can go ahead and do two-dimensional type objects and store information about that, which is very helpful when doing certain things. Off the top of my head, tags, so you can define all your tags as objects potentially, which could be a series of key value pairs. Terraform and ARM Bicep both cater to programming principles, so you will go ahead and see and feel it feels more like a true programming language rather than trying to edit a file. They both offer a command line interface or CLI to interact with. They both track dependency tracking. Looks like I got a duplicate issue there on the slide, but dependency tracking means, for instance, for Azure, if I have an app service plan and an app service, it'll make sure to deploy the app service plan before I do the app service. Again, there might be some configuration in there. You can define and reference it, but at least you don't have to know the resource ID to kind of tie the two together. Both of them offer a free version, and we'll go a little bit of Terraform, but there is a paid version of Terraform, but there's nothing stopping you from getting started with Terraform right away. There's no license or anything like that. So first up, Terraform. Terraform is created by the HashiCorp. It was established in 2014. It is open source. There's over 1,000 providers. Cloud agnostic, and I kind of have that asterisk there because I think there's a misconception out there that what I define for Azure and Terraform, I can just change one line and deploy to AWS. That's really not how Terraform works. If you stop to think about it, you have two different providers. Those two different providers have different schemas, different resources, that different properties to fill in. So it's true that you can use Terraform, the language, across cloud platforms. However, you would have to customize your application or your infrastructure as code for your destination cloud. Another key thing with Terraform is the understanding of a state file. This is kind of a remote definition file, as in, hey, according to Azure, my deployments are structured to have all these properties in it. So every time I deploy it, I'm going to run a plan, is what's known, against that state file and show what's going to happen. May that be a creation of files, creation of resources, deletion of resources, and you kind of run that against that state file to kind of see what's been defined out in Azure and then what you're really promoting. Now, some of this gets a little bit hairy when you create resources outside of a state file and you potentially have to import them in. So I just want to call out that there's a state file management piece of this. And I mentioned on the other side too that there's a paid enterprise version. Well, you get a little bit of the paid enterprise version. It's hosted by HashiCorp. It really does assist with scale. As you start to scale out, they have workspaces to kind of assist your teams in kind of that production at scale. So at a high level, kind of the pros and cons for Terraform. The pros is you abstract advanced functionality. It's just all done in Terraform, right? Because you don't necessarily care what goes on behind the scenes. You just know you define a certain way and it goes. It is open source. I'm going to put that as a pro because if you see something wrong, you can go ahead or something that needs to be addressed, you can go ahead and do it yourself. It's the same language and principle across various clouds. That's not providers. And I mentioned that, saying that you can't just change your Terraform file to point data from Azure to AWS and boom, you go. It's not going to magically know to convert app services to Lambdas, those kind of things. However, one thing to keep in mind is that if you are deploying across platform, then you might be able to get some way to say, yep, these components are being deployed to Azure, these components are being deployed to AWS. Then there's really more value there with Terraform. You can run plans. That's just a Terraform plan down there. And Bicep does the same thing. We can talk about that when we get to that one. So the cons is it's always going to lag behind the native provider. So if you think about this, and it's open source, if Azure, AWS, GCP come out with new functionality, then someone in the community has to go ahead and contribute to open source. Or vendors like Microsoft actually do contribute to Terraform, and they just have to catch up. There is a state file. I do think that is a overhead in managing it. It can be problematic if you're not quite sure what you're doing. And tracking Terraform versioning, that can be a really big overhead to your development teams. So solutions might be deployed using different versions of Terraform. And because of that, some functionality might be available or it's not available, so you have to keep track of that. Certain infrastructure of this code still relies on ARM. So certain things like logic apps or Data Factory or Azure Policy to an extent, you're still inserting ARM into your Terraform. You didn't really get away from it. And then also it's tied to the API of the provider. So within Azure, you know that there's different API versions, the different services that are made available. Well, whatever provider you're using or version of the provider ties to the specific API versions. So you really don't have control over that, which means that it could be updated without you knowing it if you've updated the provider, as well as you can't really customize it. So if I want to try the new version of the API, I'm not going to be able to do that in my current Terraform provider if it hasn't been supported yet. Another con is secret management. So I mentioned the state file. You really have to be careful of what security you put behind the state file, because depending upon how you've configured your secrets for, let's say, a key vault, can be in their state file in plain text. So it's something to be mindful of as you're creating your Terraform platform. Here's just an example of what Terraform may look like if you've never seen it before. You can see up here we're defining it as Azure RM version of at least 2.0, and then here's just a simple resource group. We give it a name, location, tags. So it's a little bit different than ARM if you played around with that. Another resource I'll throw out there for everyone here is just the Terraform website. You can go over here. There's great overviews, tutorials on how to get started with this. Again, across multiple providers. Gives you a little bit better on the features and drills in more than what we are here. I mentioned the different providers is, again, state management, dependency graphing, plan and predict changes. You can kind of go in here and see the sales pitch for it for sure. So, next up, ARM and Bicep. So ARM, if you're not familiar with that terminology, is the Azure Resource Manager. It is the native platform for Azure. It is essentially JSON files. Bicep was the production version was released in 2021 in March. It is a real language. It compiles into ARM templates. So the good thing with that means that I'm still deploying ARM. So it's not like I've introduced a new tech stack. Really, I'm trying to help with the development of those ARM templates. Talking at a high level of Bicep, it's a first-class Microsoft citizen. So what that means is that it's fully been productionalized by Microsoft. Microsoft will support it. Their feature availability is available from day one. So anything you can do in ARM, you can do in Bicep, again, because Bicep compiles into ARM. Which, going back when we were talking about Terraform, some of the cons are new functionality needs to be adopted by the open source community, or if a new APIs come out, that needs to be incorporated with the provider. Well, with Bicep, it's instantly available to you. As soon as it's released for GA, you have it. It is transparent over ARM. Like I was talking about, you can see what compiles and troubleshoot your ARM template if you're more comfortable with ARM. There is no state file, which I'm going to call as a pro here compared to Terraform. You do run a hyphen what if in the CLI to kind of show you what your deployments will do. So think of that as your equivalent to a Terraform plan. You can easily convert ARM into Bicep with a decompile command. Now that is a best guess, but it does a pretty good job. And you can kind of see with that functionality, the Microsoft team really wants to drive adoption here by lowering that barrier of entry. And it is an active product team, and once we get through the cons here, I'll pull up the repo and kind of what you can see how it references Bicep really, and you can see how active it is. The cons, it's limited to what ARM can do. So if you are familiar with doing things versus PowerShell and CLI, it's that you can do that way versus an ARM template. It's not going to solve for that. And Bicep's only going to be Azure resources, which makes sense if we're compiling to ARM templates, and ARM is the infrastructure as code schema for Azure. We can't go ahead and take Bicep and throw it at AWS. It's just not feasible. It's not technically available. So in an example Bicep file would look like this. You can see we've got a parameter. We're calling a target scope, in this case a subscription. You go ahead and name the resource just like in Terraform. Here's where you specify the API version. Give that resource group a name, location. There's the tags. So you can kind of see that it's pretty easy to get started. Same with Terraform, and try if you're used to a programming background. Some of these concepts and the way these are being declared should come pretty quickly to you. Now, as promised, I'll go ahead here and show you the Bicep, the repo out there in GitHub, publicly available. You can go out here and see they've got a README. They go through it. If you haven't noticed too, some of the Microsoft documentation now, it'll show you the ARM and Bicep in the different types of things of what you can deploy, or at least code examples. Talking about how active the community is here, and that's not to say Terraform isn't active as well, but this is active with the product team directly at Microsoft. You can kind of see where comments are getting posted on things that were opened up hours ago. So it's heavily in development, and it's definitely got more things to come. And then one thing too, if you're noticed, they do have an interactive playground with some sample templates out here. So you can go ahead here and choose one if you want. Let's go ahead. I always love to pick on a storage account. So let's just do a blob storage account with blob container. Over here is the Bicep. Over here is the ARM. You can also go ahead and put something in here if you want to play around and see. Obviously that's not a Bicep file. Compilation failed. But if you're just looking to get started and playing around, you can do your own stuff in here and do it. There's decompile. So if I want, I can throw in the ARM template and then decompile it as well. So that being said, now you got a little bit of an overview on Bicep and how it kind of plays. So, conclusion, and the one thing I want to stress here is I'm not saying that one tool is superior than the other. It's not that one isn't a valid tool, it just depends upon what you're trying to solve for, right? There's that saying that you want the right tool for the right job. Just understand that there's options depending on what you're trying to accomplish. And these are just two of them. There's other ones out there. Gulami is the one that's gotten some more attention lately in terms of being able to write infrastructure as code in a native development language. That's definitely one that I would encourage to look at. There's going to be organizational fit. So some groups are going to be more comfortable with a Terraform and some groups are more comfortable with a Bicep. It just depends upon what's the appetite for learning. If you're an organization that may not necessarily be adapting things right out of the box, Terraform might be a better fit because by the time it gets there, it's probably more stable than if it was right away in in GA. Also, existing investments. So I'm not saying let's go out and rewrite all of our Terraform as Bicep, or let's go ahead and rewrite all of our ARM templates as Terraform. There's a thought there in thinking about what's the existing investment we have in a platform, and kind of going off of that as to what the infrastructure as code provider should be. The one thing I want to call out here too is I encourage everyone to try these tools out. They're free, right? So there's no reason not to. Get started locally. Get started playing around and getting a feel for how things can be structured in this infrastructure as code language. And these are ever evolving. What we're presenting here, it's going to grow in the next 6 months, next month, next 2 weeks. Both Terraform and Bicep, I guarantee, will have something released in the next 3 months. It's just the nature that we work in the cloud. So absolutely take this as an introduction to go ahead and get started with those two tools. And with that, thanks again. My name is John Folberth. You can find me there on my website, Twitter. Feel free to reach out and connect. Thanks and have a good day.